Hello students, welcome to this particular session. In the previous lecture, we have started with the intro of integration, its geometrical interpretation, definition of integration, and we have discussed the formulas which we will be using in integration, right? In this lecture, let's practice and let's make use of the formulas which we have discussed in the earlier session, right? So, first and foremost, before attempting these questions, let me tell you one thing. In physics, if the displacement of a body is known to us, then its velocity is easily determined, isn't it? If displacement is x, then velocity is dx by dt. That is the differential coefficient of displacement with respect to time that will give us velocity. And if velocity is known to us, then the acceleration is given by the differential coefficient of velocity with respect to time. So this is the process of differentiation. This is the process of differentiation. This we have already done. We have discussed various numericals based on this, right? Now, what if acceleration is given and its velocity or displacement is to be found? Then we will follow the reverse step, right? If acceleration is given, then the velocity can be found by integration. That we will discuss. If velocity is given, then displacement can be found by again using integration. So, it's the reverse process. So, with the help of differentiation, velocity can be found if displacement is given. Acceleration can be found by differentiation if velocity is given. On the other hand, if acceleration is given, then velocity can be found by differentiation, and if velocity is given, then displacement can be found by integration. So both are inverse of one another, right? Let me try to condense this point with the help of a simple example. Thereafter, we will discuss these 8 questions. So what to do is, let us consider a body whose acceleration varies with time t as a is equal to 3t. This is the acceleration. This is the acceleration of the body. So what will be the expression for the velocity of the body and the displacement of the body? Let's try to find out, right? What's the process is? A, we are aware it's given by dv by dt. It's equal to 3t. So rearrange the terms, what do we get? dv is equal to 3tt, right? Now integrating both the sides, from acceleration we need to get velocity. So we need to integrate. So integrating, we get, okay, it will be like this, integration of dv would be equal to integration of 3t dt, right? Integration of dx is x, integration of dy is y, integration of dz is z, so integration of dv is v. 3 can be taken out, t to the power 1, so formula is t to the power 1 plus 1 divided by 1 plus 1, so it will give us t square by 2. And students, you remember constant of integration c is to be introduced over here. So this is the expression for the velocity. So look, if the acceleration is given, then the velocity of the body can be determined using integration. And if velocity is given, students, then displacement can also be found by further integrating it. I'll show you. So velocity is this. So velocity is also given by dx by dt, differential coefficient of displacement with respect to time, right? So dx can be written as 3t square by 2 plus c into dt. Now integrate it. So what we get is, on integration, we get integration of dx is equal to integration of 3t square by 2 plus c into dt. So students, integration of dx would give us x, which is the displacement, and I'll make use of it directly. 3 by 2. Integration of t square with respect to t is t cube by 3 plus c constant, integration dt would be t. So displacement would be t cube by 2 plus ct. This will be the expression for the displacement. So I am stressing on the fact that integration can be used to determine the velocity of a body if acceleration is given. It can be used to determine the displacement of the body if velocity is known to us, right? So it's the vice versa, reverse process of differentiation. So let's proceed with those questions now. Let us proceed with those 8 questions. These are, some of them are definite integrals, and where the limits are not given, they are the cases of indefinite integrals. So let's try to solve them one by one. Okay, first one. Let's consider on the first one. Constant term can be taken outside. It is basically universal gravitational constant, and these are the masses of the two bodies, right? Mass constant, G, it's a universal constant, so it can be taken outside the integration. G, capital M, small m. So we will be left with 1 by x square. It can be written as x to the power minus 2. Okay, we can integrate it. Formula you are aware, students, x to the power n, the integration of x to the power n is x to the power n plus 1 divided by n plus 1, right? So what do you get? X minus 2 plus 1 divided by minus 2 plus 1. Again I am repeating, denominator would be same as that of the power. So limits will be from r to infinity. So g capital M small m, x to the power minus 1 divided by minus 1. Limits will be from r to infinity. So minus, it can be taken outside, 1 by x. Limits would be from r to infinity. Then I have told you how to use the limits. After doing integration using appropriate formula, the limits will be substituted as upper limit minus lower limit. So what you get is minus g capital M small m, upper limit 1 by infinity minus 1 by lower limit. In place of x it would be r. 1 by infinity is 0. So minus minus get cancelled. Answer would be g capital M small m divided by r. This will be the answer, right? So this is how the integration needs to be done. I think second one is also a similar question. We can also try that one, right? It's very simple. Same way we will proceed. So let's try the second one. Second one is K is constant, charge is constant. So again, minus K, Q1, Q2 can be taken outside. Minus K, Q1, Q2 being charges constant, they can be taken outside. So, second question. So minus K, Q1, Q2, it can be taken outside, and it is x minus 2 dx. Limits are from R1 to R2. So let's try to solve it. Minus K, Q1, Q2. Remember students, just now we have done integration of 1 by x square, that is x to the power minus 2 is minus 1 by x. Just now in the previous question we have done. In this case also, we have done the integration of 1 by x square. 1 by x square is x to the power minus 2, and its integration is minus 1 by x, right? So I have used it directly over here. R1 to R2. Minus minus get cancelled. So it can be written as K, Q1, Q2, 1 by x, R1, R2. So we can substitute the limits over here. So K, Q1, Q2, upper limit minus lower limit, 1 by R1. So this is the answer of the second one, which is exactly similar as that of the first question, right? Let's try the third one. Integration of sin x, and the limits are from 0 to pi by 2. It's an interesting question and we'll be using it frequently in physics. So third one, this is it, 0 to pi by 2 sin x dx. Look student, integration of sin x with respect to x is minus cos x, because differentiation of cos x is minus sin x, therefore integration of sin x will be minus cos x. So integration of sin x is minus cos x, and limits would be written like this, 0 to pi by 2. Again, upper limit minus lower limit, so cos x is the variable, so in place of variable write the upper limit minus cos lower limit. So students, cos 90, you are all aware it's 0, cos 0 it is 1, so minus minus get cancelled, so the answer would be plus 1. Clear? So this is how the integration of trigonometric functions can also be done using appropriate formulae. Right? Let's attempt fourth one. Integration of mv dv u to v. It's an important expression. We are going to obtain a very important expression. Mass being constant can be taken outside. Integration of v, power is 1. So it will be v to the power 1 plus 1 divided by 1 plus 1. So it will be v square by 2. So it is v square by 2. Limits would be from u to v. So half v square. Limits are from u to v. So half upper limit, in place of v substitute v only. In place of v substitute u. Are you able to relate this? Any physical significance, students? Yes. Half, actually m is also there. So half m v square minus half m u square. Students, this is the final kinetic energy and this is the initial kinetic energy. So this basically represents the change in the kinetic energy of the body. Change always is final value minus initial value. So this is indeed the representation of change in the kinetic energy of the body. Right? Let's proceed with the next one, fifth question. Okay, fifth one is a good one. So, fifth question is integration of 3x plus 5 to the power 7 dx. Look, this is the master formula. Integration of x and dx is equal to x n plus 1 divided by n plus 1. And in differentiation, we used to multiply the term dx by dx, right? Here the same term will be divided, integration being inverse of differentiation. So what to do is, this entire term can be treated as u. I'll give you a reference. Suppose it's like this. U is a function of x. So integration of un with respect to x, it would be equal to u. Same formula, n plus 1 divided by n plus 1. Now remember, students, I'm going to tell you a very important point. In differentiation, we used to multiply the term du by dx. Now in integration, the term which used to get multiplied in differentiation, here it will get divided, right? So it will be du by dx. This is very important, right? This term used to get multiplied in the case of differentiation, but integration, the same term will be in the denominator, right? So make use of this concept. That way you can use the result. So let's consider it to be u. Let us consider this to be u. So it's in the form of this. So the result would be 3x plus 5 n plus 1 divided by n plus 1, that is 7 plus 1 divided by 7 plus 1. Divided by differentiation of du by dx. Therefore d by dx, and what is u? U is considered to be 3x plus 5. So what you get is 3x plus 5 to the power 8 divided by 7 plus 1 is 8, and differentiation of 3x with respect to x is 3. dx by dx would be 1. And differentiation of 5 being constant would be 0. So the answer would be 3x plus 5 to the power 8 divided by 24. This will be the answer. Right? So this one is very important. Students, just try to remember, in differentiation this term used to get multiplied with the result. In this case, it needs to be divided, because multiplication and division, they are the reciprocal of each other. So make use of the same logic. Differentiation and integration being inverse process of one another, the term which used to get multiplied in differentiation, the same thing will get divided during integration, right? So that is how such questions needs to be done. Let's consider sixth one. Students, sixth one is very important. Sixth one is very important. There is no direct formula for the integration of sine square x. There is no direct formula. So for that, what to do is, we need to make use of trigonometric formula, right? So we are aware, cos 2x, we are aware it is given by 1 minus 2 sine square x. Isn't it? From here, the sine square x value needs to be solved out. So what to do is, we can write 2 sine square x is equal to 1 minus cos 2x. So therefore, sine square x, it will be equal to 1 minus cos 2x divided by 2. So students, remember, There is no direct formula for sine square x, right? So sine square x needs to be first changed in this manner. Now, sine square x can be rewritten as 1 minus cos 2x divided by 2, right? Now we can easily integrate it. Let's open the bracket. We can write it like this, isn't it? We can simply open the bracket and rearrange the terms in this particular manner. Half being constant, it can be taken outside. Integration of dx is x. Integration of dx is x. Here, cos x. Now look. Integration of cos x is sin x. Differentiation of sin x is cos x. So integration of cos x would be sin x, right? So integration of cos 2x would be sin 2x divided by, this is not x, actually it is 2x. So it will be divided by differentiation of 2x plus obviously constant of integration k. Here also constant integration will get included. Here also constant integration will get included. The constant plus constant is the resultant constant, right? So what you get is x by 2 minus differentiation of 2x with respect to x would be 2. dx by dx is 1. Half sine 2x plus k. So this is the result. This is the integration of sine square x. So this will be frequently used in physics. Right? This is the correct approach of doing this question. Let's try 7th one. The 7th question. Okay. 7th one is pretty simple. 7th one is we need to find out integration of 2x square plus 1 dx. Make use of the same formula, right? If it is cos u dx and u is a function of x, then the formula would be sin u divided by du by dx. Just now we have discussed it. Just now we have done it. So similarly, consider it to be u. So what do you get? Integration of cos u is sin u. So that is sin. In place of u, you can substitute this value. 2x square plus 1 divided by differentiation of du by dx, right? So that is d by dx and u, which is 2x square plus 1. So what you get is sin 2x square plus 1 divided by 2 can be taken outside and differentiation of x square is 2x. Differentiation of 1 being constant would be 0. So what we get is 1 by 4x sin 2x square plus 1. This is the result. Understood, students? So again, this is very, very important. Integration of cos x with respect to x would be simply sin x divided by dx by dx, that would be 1. No need to write that in that case. If it is cos u dx, then it would be sin u divided by du by dx. This term will get divided. Right? So you can do such questions directly, right? Managing your time properly. Okay, last one, 8th. So integration of x to the power 11 by 2 dx. It's simple. So it's in the form of x to the power n. So its integration is x to the power n plus 1 divided by n plus 1. So here we'll get x to the power 11 by 2 plus 1 divided by 11 by 2 plus 1. So what do you get is 13 by 2 divided by 13 by 2. Just remember, the denominator will be same as that of the power. So what you get is 2 by 13 x to the power 13 by 2. So this is the result of the last question. So students, I hope I am able to convince you regarding the usage of integration in physics. Do practice more and more questions, as I have told you very often, and you will find physics much easier using these mathematical tools, right? So all the very best. We'll continue in the next session then.